And hello, everybody. I'm very excited to be here and to talk about something that is very interesting to me as a developer and should be interested to you as a developer. Before I'm starting, I want to start with a small quiz. Um, what do you see here? I give you 2 seconds because you shouted at the screen, I see Apple logo. And what do you see here? If you said 3 nines with different colors, then you're probably not on the way, but this is Chrome logo. And what is missing in this picture? So if you like cars like I do, you were missing the BMW logo, but if you saw this car and its design, you probably, if you know cars, knew that it is a BMW. And this brings me to the topic that I'm going to talk about. First of all, a brand like BMW, Chrome, Google, Apple, and things like that distinguish your product from other products. And design systems, like the design of the BMW that we saw, can help you distinguish your product from other product as well. And as Mike introduced me, I'm Gil Fink. I'm a CEO of Sparksys. This is my own company. I'm both a Microsoft Most Valuable Professional and a Google GDE for Web Technologies. I wrote a book in the past called Pro Single Page Application Development back in 2014. Some of the parts in it still relevant for today, but it was written in Backbone.js. I won't say that word again. So what we're going to do in the next 25 minutes. First of all, I'm going to tell you or present you design system and why as a developer you should care about design systems. Then we will talk about how we can create a component library using Stencil from Ionic and Storybook. So let's drill down. What is a design system? If you're not familiar with this word, it's a set of different common rules, constraints, and principles and best practices that are part of the design of your entire company's products, both in code and in your apps. So the parts of design system or the core components of a design system, you can see that in the slide. These are the different colors that distinguish your brand from other brands, like, for example, the logo of Chrome that has the colors that are part of the material UI design system that Google created. Iconography that gives you different icons that were produced to give away things like, not things, but icons that your company is responsible for it. Copy, elevation, how you lay out things in your web page, animations, how the animations in your web page look like, the transitions, how they are produced and things like that. So probably as a developer, you ask yourself, why should I care? Design systems distinguish your brand from other brands, and they give you UX principles that applied on all the application in your company or other applications that you create for consumers. And if the consumers look at your application and they identify that it's from your company, then you did a good job. One last thing is design systems are probably can created as a shared component layer, and that is related for micro front-end architecture, because one of the ways to create micro front-end architecture is shared component layers. We'll talk about it later. Now, as a developer, you ask yourself, okay, so we have design systems. Again, why should I care? Because, designers, they will create the design in Figma or in other tools, and they will give it to us, and we will create the application. But what I see in companies that I'm consulting in is that you should establish a language, a common language between developers and the designers. And this brings me to the topic of atomic design. Atomic design is a suggestion by Brad Frost that gives a common language between developers and designers. And the idea is to take some chemistry ideas and put it in the language that we are discussing. Okay, so it is created from 5 different parts: atoms, molecules, organisms, templates, and pages. Let's talk about atoms. Whenever a designer talks with you and he says something in his language about some small parts of the application, the bits and bytes of the application, these are the atoms of the application. An atom, like in chemistry, is the smallest part that you can compose from it much bigger molecules and organisms. For example, if we're talking about HTML elements, these are the smallest parts that we create from them our elements. So, for example, you can see on the slide a label, an input, a button. These are the atoms that are the smallest parts in our application. And on those components, we can create some different design, okay, to distinguish our applications from other applications. Let's move on. Molecules. When you take 2, 3, 4, whatever atoms and you combine them together, you can create a molecule. A molecule is a combination of different atoms that have some different functionality from the functionality that you receive from the atoms. For example, this search part in the application includes a label, an input type, and a search button. And these are combined into a different functionality than a button, an input, and a label. If you are creating a much bigger hierarchy, organisms. An organism is a bunch of molecules and atoms combined together and composite together into some organism in your web page. For example, what you see here, the header of a web page can contain a lot of different moving parts. So now let's move from the chemistry part of the suggestion of atomic design, and let's talk about template. The template is a composition of different organisms, atoms, and molecules into a template that defines how the page will look like, but without the content of the page, because content of a page can move some parts and do some different things on your web page. So these are the templates, and when you talk with designers, when they say templates, they are saying this part without any content. Last but not least, pages. A page is just an instance of a template that includes the content inside of it. So now, when we have a common language between designers and developers, we can continue, and let's move on and let's talk about component libraries. How component libraries relate to design systems. So in most companies, whenever you get the design system from designers, you will create a component library that includes most of the moving parts of the design system and expose those moving parts to your applications. A component library is just a clear standard to determine how your components will behave, can be configured, or should be used. Okay, so let's start with our first demo, and let's build a stencil component library. I'm a little bit getting ahead because I did the npm init stencil in command line. When you want to create a component library using stencil, you will write npm init stencil. Then you will go into that the folder that was created, do npm install. I don't want to, that we will waste time on npm installs and on the initialization of the component library. So I already created that. So here we are in the component library that I'm going to create, and I started to create my Dino components. So again, I ran in command line npm init stencil. I chose that I want to create a component library, and then I did cd and got into my my Dino components folder, did npm install, and this is the output. Now, what we are going to do is I can start by running this application, because it was created and it will run. Okay, so here it is. It does nothing. It includes some component, starter component that can show you how you can create things in Stencil. Okay, this is my component, but I'm going to create my own component, my design system component. So let's stop the server and let's do npm run generate. And this is a command from Stencil. Okay, it is a part of the scripts that are added to a component library that was generated by Stencil. It asked me the component tag name, so let's create a Dino button, and you can specify which things you want to create. For example, I want to use CSS as my style sheet. I want to create a spec file. I want to do E2E testing file. And I'm just going to press the enter button, and I will let Stencil generate my component. Okay, so it generated a few things here. The Dino button. Okay, so let's create our Dino button. Okay, so this is going to be the code of the Dino button. It's a component. The tag name that I'm going to use, that Stencil will compile and use later on as my my HTML tag, because Stencil, I didn't say, but it's a compiler that generates standard compliant web components. So the web component that is going to be generated by Stencil is Dino button. It's going to use the Dino button CSS file that was generated for us. It is going to use Shadow DOM. Okay, I'm not going to jump into the concept of Shadow DOM. I urge you to go and read about the Shadow DOM API later on. Then I'm exposing a text that is going to be written as part of the button, and I'm going to expose the ability to give me what I'm going to do whenever the button is clicked. Okay, so this code is going to generate a sophisticated Dino button. Okay, let's move on and let's give that button some fancy style from our design system. So here is the style that I'm going to use. That's less relevant. And let's go to this HTML file here. And instead of using my component, let's use the Dino button, okay, with the text click me. And I'm going to add some button wiring. Okay, so I'm going to write to the console that the Dino button was clicked. Now I can save my component and I can run the Stencil development server again, and voila. If I did everything right, then we are going to see a Dino button. Where it is. Take some time, and here it is, a Dino button with an icon of a T-Rex. Yay! And when I click it, you don't see it, but let's open the console. I'm clicking the Dino button, and Dino button clicked. Okay, so I have my component, I have everything, and I have an HTML file that gives me the ability to see what was created. But that's not enough for me, okay? And this brings me to the next topic, which is we created our Stencil library, and we want to expose that Stencil library to our designers, because I want the designers to look at my created component library and say that it aligns to the design system. How can I do that? This is where a tool like Storybook comes into play. If you don't know what is Storybook, Storybook is a UI development environment. It can help you visualize in lab environment how your components are created, not in the HTML file that we saw early in the component library currently, but rather interactive way of using the components. You can get a lot of information from it, and you can use this the Storybook tool in order to show the designers how your design system or how your components were created. So if you want to run Storybook, you just need to type npx sb init to create a Storybook in any library that you created, not only in Stencil, but rather you can do it in Angular, in React, in Vue, whatever. And Storybook scripts will try to figure out whether you're using any of the frameworks, and then will initialize Storybook for the relevant framework. Whenever you're going to use Storybook with Stencil, you can give Storybook a hint that you're going to use the type HTML. It is here. Okay, so you will do npx sb init with the flag type and HTML to produce a wrapper of Storybook on top of web components, because Stencil is going to generate web components for you. Once the CLI ran and Storybook was installed, you can do npm run Storybook and see the output, and we'll see that in a few seconds. Whenever you want to write stories in Storybook, you're going to create a template. And each entry in Storybook is a file with the postfix of stories.ts, tsx, js, or jsx. The story is just a visualized test for your component. So as you can see in the slide here, you will create a template wrapping the component that you created. And then you will bind the template with some object with configurations if you want, or you can add the configurations later on, and the spread here will spread this configuration. So without any other interference, let's add Storybook to our component library. Again, I already did that. I did npx sb init with the flag HTML beforehand, because it can take some few minutes, like 5 to 7 or even 10 minutes to run and build the Storybook for you. What I'm going to show you is, once you have Storybook, you have the configuration of Storybook here. We will talk about what we are going to do with them later on. We have our components in the Stencil component library. It will add to you some stories that you can use to see how you can write your own stories later on. And if I will open the folder here, or the tab here, you can see Storybook currently running. This is my current Storybook in the Dino components library. Okay, it doesn't expose my Dino button because I didn't do anything. I will show you how you can configure Storybook to use Stencil. And these are the things that Storybook added for you. For example, you have a button. You can use Storybook tabs to play with the button. Currently, it's primary. If I'm not doing primary, it will remove the color here. You can play with anything. Okay, as I said, it's a UI playground for your application. Let's choose a different color to our button, and you can see here that in the canvas how the button looks like. You can go to the docs, and every developer that want to look at your button and how to use it, you can show him, okay, this is a button, okay, with some configuration. These are the configurations that you can use, and etc., etc. And it is very, very helpful. So how can I wire Storybook into my component library. So again, after you created the storybook or added the storybook to your component library that was created with Stencil, I'm going to do npm run, build, and I'm going to build the component library. Why I'm doing that is because Stencil will generate a loader folder for me, and that loader will enable me to use the Stencil components inside Storybook. So we will wait a little bit that my development environment will show us that we have a new library, new folder loader. Okay, so again, do npx sb init, then build your Stencil library to produce the loader, and go to the preview.js and just import the defined custom elements from the loader and then run it. What it is going to do is it is going to define all the custom elements from your component library and for you, and you will be able to run them. Now, when we have that in our code, I can go to my Dino button, and I will add a new file, a new TypeScript file. Let's call it Dino button.stories, and let's generate it as a TypeScript file. And I can do something like this. I can export the story. Okay, this is going to be the title of my story. I can create my template from the Dino button with the arguments that I'm getting. I'm not spreading the arguments here. I'm just adding the text here and bind it to the object, and the arg is going to be Dino click. Now I have my story in Storybook, so I can do npm run Storybook to run Storybook and see how it is producing a visual test. Okay, Storybook is running, so let's move that to a different port because I didn't stop here Storybook. Okay, I can go to the components here. Okay, and voila, here is the Dino button. Okay, let's see it in the canvas. This is the Dino button, and we have the text wired, and everything works as expected. And voila, we have our component library exposed as a storybook. Let's move on. And what is helpful in Storybook with Stencil and together is that you can expose that component library as a web application. You can use the npm run Storybook build and produce a build from the component library, and then you can put it inside some web server and say to the designers in your company, hey, fellas, we have the Storybook here. If you want to look at the components that you introduced in your design, go ahead, use this URL, and you have a lab environment that you can use the components and test them. If you want to test languages, different languages, internationalization, localization, things like that. If you want to test anything regarding the layout that the component should have, things like that. And it is also enabling the other developers in your company to look at the code in your shared component library, and to understand how to use your components and how to write your integration with those components. So what next? Wrap it and publish it. Publish the component library. Okay, so you can take the component library and just build it. There is a build step in Stencil, and just put it on NPM, and people will be able to use your component library or your design system component library. Again, you can expose the Storybook build as a server and give links to your UX team to look at the content, and then you will be able to talk and share your thoughts about how things should look like. And when you have the atomic design idea, you will be able to talk with them in their language. And of course, you can add your more components to your component library. I'm not expecting that you will have only button in your component library or a Dino button. So let's summarize. Building a design system is a necessity for any company that I'm consulting in. And creating your component library can help you achieve your design system goals and can help you have a common language with your designers in your company. With that, thank you very much. And if you want to follow me, I'm at Gil Fink in Twitter. If you have any questions, I will be happy to answer.